Hi, welcome to lesson 11 in the series of 8051 microcontroller programming and interfacing. For more information, you can visit us at www.jcbrlabs.org. You can also download the required software for programming the 8051 microcontroller and other related documents on that website. In this lesson, we will talk about how to interface a LCD with microcontroller or with 8051 microcontroller. So first let's have a look on the type of LCD which we are discussing, because each LCD or each display unit has a separate controller within it. So each LCD or a display unit has a separate command or separate procedure to interface or to display a data on it. So in order to write a program for displaying some information on LCD, first we need to understand what kind of LCD it is and how to write several functions on that LCD. So let's have a look on the kind of LCD which we have. So we have this LCD 16 by 2 LCD. So what we mean by 16 by 2, we will discuss it. It has total 16 pins which are starting from pin number 1 to 16, and here all the information is written there, like what data should be sent to which pin. So like pin number 1 should be connected to ground, then pin number 2 should be VCC, and then pin number 3 should be ground for better contrast, and then 4 is a register select, 5 is read and write, and 6 is enable pin, and then 7 to 14 pin are the data pins, and 15 is LED plus, that means VCC should be connected, and to the 16 pin again ground should be connected to it. So this is a kind of LCD which will be interfacing to a microcontroller for this lesson. Similarly, if you have some other kind of LCD and if you want to interface that LCD, you need to first go through the data sheet of that LCD and you need to understand, okay, what command should be given for displaying purpose. So now let's have a look on the various commands and various aspects of this LCD. So let's have a look on the LCD structure. So we said this is a 16 by 2 LCD. What do we mean by that? So this LCD have two rows, that is written by 2. This is row 1, this is row 2, and its address starts from 80, and it has total 16 address in one row. So 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and then 15 and 16. Similarly to the other row, this first address, this one is, which one is this, its starting address is 80, and obviously this is ending address will be 8F. So if we want to display any character and at any specific location, we need to provide the address for that. The address of the second line for this LCD starts from C0 and it goes up to the last address is CF. So again there is a command to, so if we want to display our content in the second row, second line, we need to give it from C0. Similarly, there are several other commands. So let's have a brief look on these commands. So these are the several commands of this LCD, like 0x01 if we send to it. Okay, prior to it, let's have different things. It has 3 pins mainly and 8 data pins. So data pins starts from, goes to D0 to D7. All other pins were just for power supply and other things. The most important pin is RS, RW, and your enable pin. So RS stands for register select. Register select means whether we want to select command register or data register. Command register means we need to send command, okay, move the cursor to 80 location. So that will be command. And when we want to display a content or data like display as there, that will be our data. So there are two things, command and data. So rs could have two states. If rs equals to 0, then command register is selected of the LCD. If and rs is equals to 1, then data register is selected. That means data means whatever we want to display. Similarly, read and write. If rw equals to 0, that means we are writing something to the LCD, and if rs equals to 1, we are reading something from LCD. And then enable pin. So this enable pin should go from high to low pulse. That means a high to low pulse should be transferred, and that should be of minimum of the duration of this pulse should be 450 nanosecond. So a 450 nanosecond high to low pulse should be transferred in order to whatever content is available on these pins to send them inside the LCD register. So there are things like, suppose we want to write a command, so command data or whatever command is there, that data will appear here, and then we will send a high to low pulse on enable pin, and all the command will go inside the LCD. When we want to display a data, that data will again appear on this data pins. We will set our register select to 1 in order to make it data, and then again high to low pulse will be transferred to enable pins, so that whatever value is present on these data pins, that will latch inside the LCD. So this is the simplest procedure for writing some data into this kind of LCD. Now there are several commands which are used to display our data on this LCD, and some of those commands are given here. So 0x01 clear screen, 0x38 it starts functions at 8-bit data, 2 line and 5x7 dot. 2 lines means these 2 lines are initialized, and character is displayed in the form of a matrix. So there are 5 to 7 vertical lines and 5 horizontal lines, and based on that some of the content whatever we want to visualize it, that will be displayed here like this one. Specific dots will be marked. So this is to initialize it, and similarly 2.8 is used to initialize in a 4-bit operation. Like if we can also write the data to LCD in a form of 4-bit mode. Then 08 is display of cursor off, and similarly you can get this command list on the website. Similarly 80 is used to cursor to beginning of the first row. Like similarly we want to start from this one, and C0 if we send, it will force the cursor to start working from this location. And then if we want to make a moving display, then this 1.8 and 1C command is used. It shifts the entire display towards left or right. So these are some of the commands, and most probably command which we'll be using in our program will be 0x38. So it first initialize this LCD, and then we will clearing screen like 0x01, and then we will be making display on, cursor blinking, that will be 0x0a. So in this initialize LCD, this clear screen, and this cursor blinking. And then we'll send out data. So more will be clear when we will write a code for the same. So now let's write a code for it. Let's open Keel and let's create a new project. So LCD_1 LCD, and then select HTML microcontroller 89S52. So, and let's start a file. So let's save it like lcd.c, and now add this file to the project. And then save options. That's 12 megahertz, and output is create hex file. Now we can write it. Now, prior to writing the code, we must know how we are making our hardware connections. So let's clear it, like how we have connected our LCD to the hardware. So in hardware, what we have assumed, or how we have connected, showing it. This is our 8051 microcontroller, and there are 3 pins. This pin is connected to RS of the LCD, and it is connected to pin 1.0 of the microcontroller. This is read and write, and this is connected to 1.1 pin of the microcontroller, and there is an enable pin which is connected to the LCD, and it is connected to 1.2 pin of the microcontroller. And similarly, data DB0 to DB1, these are 8 lines. DB0 to DB7, these are connected to the port 2 from 2.0 to 2.1. So these are the hardware connection, and this needs to be clarified prior to writing a code, because only then we will be able to write a code to display a character on LCD. So in our first program, we simply display character S on the LCD. So in first program, we simply display only S on the LCD, and we will learn how to display a complete string and other things as well. So let's start writing. Let's start hash include reg52.h, and then let's define the signature for several functions which will be using ms delay, unsigned int used for delay purpose, and then void LCD command. So this function will be used to transfer the command to the LCD, and because 8-bit data size which are going to be sent 8-bit, that's why we have used unsigned char type variable, and then void LCD data unsigned again char. Now let's define LCD port, so that we don't need again and again. Our LCD port is data pins are connected to port 2, so we have defined it like define LCD port. Now there is one thing in C language, we can define single bit for the microcontroller for 8051, and the procedure is using S bit. So this S bit command is used to define bit addressable registers, and we can define single bit with any number. So let's define RS equals to, because it is connected to pin 2.1,
this should be pin
so
1.0.
if we want to write it P 2.0, we will write like that, P2 power and then 0. Similarly, S bit read write equals to P2.
This is P1.1.
So this is the procedure way to define a single bit inside microcontroller in a form of a variable.
This is pin 1.2.
Now let's define our main function. So let's say void ms delay unsigned int t, and this is like our previous program for delay, and let's say for I equals to 0 to I is less than t, I plus plus, and then for I equals to 0 to I is less than not I, j equals to 0 to j is less than 1275, and then j plus plus, and then bracket is closed. Now let's define our LCD command. So unsigned int, this command is coming in C. Okay, sorry, it must be char, because we have defined in the signature as char. So our LCD will be equals to C, and then our RS should be 1 because we are selecting the command register. So selecting command register of LCD, and then read write should be 0 because we are writing, and then enable pin equals to 1, and then we provide some delay, let's say for 10, and then en should be 0. So this is how we are writing command. First we select command register, and then we send high to low pulse to it. So at a specific pin PN, port 2.2, high to low pulse will be transferred. So now we will write function for data register. So LCD data unsigned char d for data. So let's say LCD equals to d, and then let's say RS equals to 1. So no, RS equals to 0. So selecting data register of LCD. Wait a minute, I think we have done something wrong. For command register, RS should be 0, and for data register, RS should be 1. So we are selecting data register, yes, and remaining same, read write equals to 0, and then enable is equals to 1, and then ms delay, and then en should be goes to 0. So high to low pulse is transferred. So when RS equals to 0, command register is selected, and when RS equals to 0, our data register is selected. So now these functions have been written. Now we can go to our main, and we will write from starting, like first we initialize our LCD. So it is command LCD underscore command, yes. So we are transferring 0x38. So this is initializing the LCD, initializing the LCD, and then we'll provide some time to the LCD to take that data, and then we'll send 0x. We will clear the display 0x01. So clear display. So if anything is there, that will be removed, and then we will display on and cursor blinking. So 0x 0e will start display. So display on and cursor blinking. So again must delay of 10, and then we'll start from where we want to display our data. So let's send LCD command 0x. So when we say display on cursor, it is auto increment mode. So if at particular location content has been displayed, cursor will move shift to the next location from where we are starting. So let's say we are writing 82, so it will start at the third location of the data. Then now we will display, because we want to display in our first program simple s. So LCD data, now display data, display data. So once you know the procedure how to write it, now if you want to display any other thing, that is just you are playing with these commands. So let's say and provide some delay. So even if we end it and if we are not putting this particular code inside a while loop, it will display once only, and then it will continuously stays there. So once data is sent to the LCD, that will stays there until its power is turned off. So now let's first simulate it on the Proteus. So we have selected, we have already made the connections diagram on the Proteus. This LCD was selected from here. Just type LCD and then you will get 16 by 12 alphanumeric LCD. So you just need to select data pins and command lines. All other things are there already. So let's put a hex file which we have just created. Okay, I think we have not compiled it yet. Yes, so let's compile it and see if there's no errors. Now, okay. So let's see. It seems like it is not displaying anything. Okay, let's change with this one. Display on, cursor blinking, and 0x 0e. And making its position, let's see, 5. And because sometime the LCD which is inside this one, it's a little bit changed. Okay, it is not working somehow. Oh, we have there was an error. We have selected this port 2 while this should be port 1 only. Okay, now let's again try it. Okay, so S has been displayed. So by default it is running it again and again, so S will be displayed. Now let's see, this is how we have displayed the character. Now let's see how to display a complete string. Say, let's define first unsigned char data. The data is a type string, and we defined here string jcbro labs. And so if we want to display it, we need to make it in while loop. So while string I is not equals to the end of a string. So if you are familiar with this C programming, you understand what I am writing, and then it will display the complete thing. Now I is not defined, so let's define unsigned char I, and we are making it I equals to I plus plus, and then after this while loop we are making again I equals to 0. So let's see how it works. Okay, now let's change it. Okay, we have not changed what is inside written. Okay, so we will be keep on transferring the str of I. So I location is increasing, and we are sending one by one character at a time of this string. This is very simple. Now jcbro. Okay, so character I is not incrementing, so let's simple write I plus plus, and let's see. jcbro labs. So this was the simplest one to write a simple command on the LCD. Similar, we can also write a rotating display, so you can understand how to write it. Now let's burn this program on the LCD. Some modification, we want to make it again and again, so we need to make it in while loop, and then in while loop each time we need to clear the display. So LCD command 0x01, so it clears the display, and yes, and then we start to display at from 0 location. So LCD CMD 0x80. So first it will start from 5th location, next time to start with the starting location. So now let's burn hardware on our on our microcontroller or on our setup. Go select hex file, open, and then upload hex. Now it's being uploaded. Let's wait for some time and let's see. In the meantime, let's disconnect it, and you can once it is done, okay, let's wait for it. downloading finished. Now let's see how it is displaying on hardware. So this is our setup. This is our LCD connections which we have made it towards the port 2 of the microcontroller, and command lines are connected to the port 1.01.1.1.1.2, and this is how it is displaying on this LCD. So clearly the text is clearly visible to it. It is displaying JCBRO labs. So try it at your hand, and if you face any problem you can comment below this video. Okay, you have seen how it is being working on the hardware, and it's working fine. So this is how we can interface our LCD with the 8051 microcontroller. So you can try with writing different codes and different patterns on this LCD by just changing some of the commands and the way you are sending these commands to the LCD. You can also write some of the custom functions with, like for displaying a complete string and so on, and for making rotating patterns, and whatever you want you can now do it. So I hope you understand how to interface this LCD 16:2 liquid crystal display to the 8051 microcontroller. So if you face any problem you can comment us below this video, and we will surely revert to that comment. So that's it for this video. Thank you.